So let's get started. We need an add, a contains, and a size method in our Arrayset class. And since it's going to be an array-based solution, we must need some kind of an array. So I'm using here t as my type parameter, but of course remember this could be anything, but I'm going to go with t. And so I'm going to have a private t array, which I will call, I don't know, items, let's say. And then when I run my constructor, I will say items equals t cast object. And I'm just going to pick the size 100. And that is just what we have to do. So remember, we have to do this ugly cast, as you guys know. Now it gives us a warning, but there's nothing we can do about it. Because we're going to support a size method, I think it's also nice to have a size variable. It's a very common thing to do. And now let's think about what contains might look like. Okay, so now we need to look in the set to see if we have x. So what we're going to do is we will say for int I equals 0, I is less than, and we're going to say size, because we only need to look up to the current number of items in the set. And then I will say if x dot equals items I, then we'll return true. And if we get through the loop never seeing the item, that's how we know that it's not there. We'll say false. Now, quick reminder, we've mentioned this a couple of times, but it's very, very important that I say x dot equals here. If I were to do this instead, I'm in danger. Because it could be that maybe my set contains, I don't know, the strings cat and fish, and then I try calling contains cat. If we use equal equals, it will compare the memory box address of this cat string and the one inside the set, and they may not be the same instance of the string cat. So instead, by using dot equals, we're going to check that the items are semantically equal. And that will guarantee that even if these are different cat strings, they are still considered equal by the string class. Okay. So now that we've written contains, hopefully it works. Now ideally we would have some tests and we would write some, but instead I'm just going to use the visualizer and try and showcase that it works. Okay. So let's now add some things to our set. So if I want to add an item, the first thing is that we need to make sure that this item is not already in the set, because our set is only allowed to have one value of a certain value, one copy of a certain value. So first we're going to do this. We're going to say if contains x, then return, because we don't want to add multiple copies. Otherwise, what we will do is, well, one of the invariants of our set, we can say the next item to be added will be at position size. And that I'm doing by analogy with our array list. So I'm remembering that invariant, so I'm going to use it again here. And so what I mean by that is we can just say item size equals x, and then we'll say size plus equals 1. Okay. And then lastly, we have return size for our size method, and that's it. And here, let's give this thing a test drive. So I'm going to take this away for now. We'll add that back in a sec. We'll see that that's a bug. So let's try running this code and putting it to the visualizer. So after I've added two items, horse and fish, if we look in the visualizer, we have an array with lots and lots of spaces. And so horse and fish are in positions 0 and 1. After I step one step, house appears. And then if we try and add fish, well, we see another fish is not added because it was already contained. Okay, so things look like they're working pretty well. We can print out whether or not the the set contains horse and its size, and we should get that these are, if we look, we see true. It's very small on the screen, sorry, and 3, which is also what we want. Okay, I have no easy way to change this font size right now. Okay, so good. We built our basic array set, and so here it is in the slide version. So if you'd like, you can look at these in the slide. I'm not going to go back over this because we just wrote it, but there you have it. The one last thing I want to mention is a piece of terminology I don't think I mentioned before, which is that when you use an array set, this variable at the top of the class here, or this t at the top of the class, it is known as a generic type variable. And when we actually use an array set, we provide what is known as an actual type argument, and you can imagine that string gets substituted in for t everywhere. And I think you've probably picked that up by context, but just to be clear, that's what's going on. You think of this as a variable that represents an unspecified type at the time that set was written, and you can provide an argument that fills in that type. Okay, so we built our basic array set, and so in the next video, we're going to start tackling a few issues and making our set even better.